Hey, Dad, what is this thing right here?
That's a megometer.
Megometer? This thing
Yeah.
looks massive compared to this one.
Yeah.
Multimeter right here, and this is a megometer?
Right. You know what this thing does?
Has mainly for commercial, industrial, right?
Measures resistance, right?
Yep.
Puts out 1,000 volts. We're going to test it right now.
1,000 volts?
1,000 volts that puts out. Let's see what's going on.
All right, let's see. Hey, Dad, what's the difference between resistance and continuity, and why would I need to use this mega ohmmeter?
It's a great question. So, the mega ohm meter is much more powerful. It's a specific meter with just one testing parameter, resistance, right? Continuity and resistance. This is a multimeter that does AC, volts, and resistance. So I'm going to show you the difference between these two meters and why it's so important to have a mega ohm meter in certain applications and when you would use it.
Okay.
So the first thing is, how do we measure resistance, right? We measure resistance if we go to Ohm's law. Ohm's law says that if we take voltage divided by current, that's resistance.
Okay.
So basically, any meter that's measuring resistance has to have its own voltage source. So it takes the 9 volts that's inside the meter, okay? Adds some capacitors and adds to a voltage, and we're going to test that. And that's really the difference. How much power this could put out to do a test versus a mega ohm meter to do a test.
Okay.
So the first thing we'll do is, let's see how much power we have. So I've got 3 meters here. The fluke meter here is going to be our test meter. We're going to use this to test the voltage.
Okay.
Because again, we need voltage and current to measure resistance, right?
Right.
So these meters are going to generate the voltage, and it's going to determine how much current it's going to take for that voltage to return, and it's going to give us a resistance measurement. So if we look at this meter, this is a Testman meter. In fact, this is the only Testman that I'll endorse.
Okay.
The 569A. I don't like these little ones, these auto sensing ones.
Why?
Because these can confuse a younger person, all right? Because it's auto functioning, it's cycling between continuity, amps, voltage. It's just constantly cycling, and a lot of times, if you don't know what you're reading, you could get a false reading.
Yeah.
So this is fantastic if you know what you're doing, and it's just like a throwaway meter that you keep in your junk drawer.
Okay.
Same with this one. This is a great garage meter. You don't want to show up on the job with this, but let's get started. So what I've done is I've got one set of alligator leads right now, and it's plugged into this meter. And I'm going to select ohms right here. So we have ohms and we have continuity, okay? If you also look, this is a dual function. So this has a diode and continuity. This is ohms and capacitance.
Okay.
So there's 2 different measurements for each location based on this function button. But I don't want to confuse you, okay? So let's do the first thing first. Let's turn this on, and we're going to go to ohms. Now, when we read what we're reading, I'm actually reading 1.4 million ohms.
1.4 million?
Yeah, see the M?
Yeah.
1.4 mega ohms that's running through this meter.
Okay.
So this meter, this lead, by the time it goes through the circuitry and comes back out, it's actually 1.4 mega ohms. Now, how is it coming up with this reading? Well, it's inducing a voltage, okay? And usually it puts the voltage out actually on the hot leg.
Okay. Which one's the hot, like the black one?
The black one actually, when you connect a meter to do ohms, and especially mega ohm meter, you always put the positive on the ground. Or the case.
On the ground. Okay.
Yes, and you put the negative on what you want to measure, whether it be the winding or the wire.
Okay.
Let's get started. So we could see right here, my fluke is reading 0.
Okay.
And that shows how poor and how low this meter is putting out power-wise. It's not even reading a voltage, a DC voltage. Now, if I go and switch it over to continuity, right?
Okay.
We go to continuity, you can see here, it actually jumps up to 1 volt.
Oh, wow.
So continuity is basically a shot that says, hey, I want to see if this is like a straight short circuit, right?
Okay.
We want to measure a short circuit. Continuity. Is a fuse good?
Yeah.
Is the switch good, right? Resistance will vary based on, it will increase or decrease to find the actual resistance, right? It needs to vary the output so that it can determine how much resistance there is. So that's why continuity is actually showing more power than resistance. And it'll even show more if I go to the diode test. So this symbol here is a diode.
Oh, I didn't know that.
A diode is a silicon junction, okay?
Yeah.
That only allows current to pass one way. So if you can see here this arrow and then the line. So current wants to pass through from the anode to the cathode, okay? That's what that's called, anode and cathode. I had to think for a second. So current will only pass one way in a diode and not the other way.
Okay.
So if I actually put that on, which it's on continuity, if I hit this function button, now it's on diode. I see the diode signal. And if you look, it's 2 volts now.
Oh,
so it's actually going to be putting out more power in order to measure through that silicon junction. All right. So we've got our 2 volts for a diode. We go back to continuity. We've got just 1 volt, and then for resistance, we actually read nothing.
Oh.
So now let's see what this guy does. So what we'll do is we'll shut these off. Now I will say that a megometer.
Yeah, where do you get something like that? I don't find that at Home Depot.
No. You wouldn't find this at Home Depot. I mean, this is a specialized meter, right?
Okay.
So this you could get at the supply house. You get this on Amazon, on eBay.
Okay.
Right? You can find these used often. You can see the condition of this one. But if you take care of your meters, they should last a lifetime. This meter is probably 30 years old.
How much is this meter? And like, if I want to go get one,
these meters are usually around $1,000.
Okay.
If not, could be a little bit more. You can check on Amazon. I can leave a link.
All right.
All right. So what I've done was I've taken the alligator leads and I put them into the megometer, taking them out from that one. So first thing we're going to do is we'll turn on this meter, right? And we'll see. Now, I will say that a megometer has usually 5 position settings.
Okay.
It has 3 powered settings. If you look on here, they're yellow. They're yellow for a reason because they're caution. They actually induce a super high voltage.
Okay.
This meter with the 6 AA batteries can put out to 1,000 volts.
That's insane.
Right. So we should read 1,000 volts on this meter, DC, but at a microcurrent.
Okay.
Very low current. Now, let's also, the reason I wanted to bring that up was this only will measure up to 400,000 ohms. Say you've got 20 ohms and you've got 400,000 ohms. If you remember, this was 1.4 meg. This won't read 1.4 meg. The only way we can do that is to power it. So we're going to try. Let's see what we get. Let's start off first with the, let's go all the way over here to the 20 ohm.
Okay.
And it's reading open loop, meaning that it's more than 20 ohms. Obviously, this is 1.4 ohms. Now, you could see this is reading 7 volts.
Okay. Yeah.
This was reading 0, right? On the resistance, this is already reading 7 volts. So right away, this tells you that this is a much bigger, better meter for specific. We can get into some of the reasons why you would use this. So I'm actually more than, so I'm reading open loop or overload, right? If we go to the 400, I should be reading, what would I be reading when I hit 400?
Nothing, 0, right?
I should be reading the same open loop, right?
Open loop, okay.
Overload.
Yeah, overload.
Because 1.4, we knew from measuring this is 1.4 million, right? And this only goes up to 400,000. And if we look, we've dropped down to 5 volts, okay?
Yeah.
So you can see on the lower setting, it actually goes up to 7 volts. As we go up to a higher resistance, it actually drops down to 5 volts.
Okay.
Now, let's go to the first selection of the powered unit. Now, this is the function of a megometer. So what's happening is, first thing this megometer is doing is saying, hey, are you connecting me to anything that has a live voltage?
Okay.
If you do, I'm not going to allow you to make the test. if you notice, it's not testing anything. It's actually measuring. It's measuring the voltage right now.
Oh, I see. Yeah.
Right? Because I'm going to induce 250 volts on this right now.
How?
And by pushing the test button.
Oh, okay.
But if this was energized circuit, the unit's smart enough to say, I've sensed voltage, I'm not going to operate. So you have to make sure it's a de-energized circuit.
Okay.
Right? And now we're going to hit the test button. So if you want to press that yellow button,
okay,
while I look at, go ahead, you can press the yellow button and hold it. And you can see this is 270 volts. And it's at 0.92 megawatt, that is.
Whoa, that's insane.
0.92 was the resistance, right?
Yeah.
Now let's fire it up to 500 volts.
Yeah.
And then again, it's going to look for voltage. It doesn't see any voltage.
But if I press
And it also has an alarm feature here where I can set where if I'm doing something repetitive and you know, I'm not paying attention, I can have an alarm. So if it reaches a certain threshold, it gives me a tone.
Yeah.
Right? So I can turn that off for now. I'll turn that part off. And then what I want you to do is actually press the test button again.
Okay.
And we'll see what we're reading on the meter here.
All right.
Go ahead. 528 volts. And again, we're at 0.93 mega ohms.
Wow.
Okay?
Yeah.
Now, this was reading 1.4. I have a feeling that's incorrect.
Okay.
Right? Something that's cheap, Chinese, quick meter. I wouldn't follow that over this meter.
Yeah.
Now, let's go one more up. This is 1,000 volts.
Yep.
Do you think this thing is going to put out, I'll turn the alarm off. Do you think this is going to put out 1,000 volts?
Yeah.
Let's try it. Hit that yellow button.
Oh my God.
You know what? I think the battery just went out.
Oh, okay. Well, that's insane. When would you ever use this in only commercial, right? Commercial, industrial?
Yeah, so the battery just died on me. So this has six AA batteries. Okay, so you would use this. I'll give you an example, and here's the instruction manual for it. Here's a perfect example of how you would use it.
Okay.
So let's say you show up and you've got a trip circuit breaker on a machine, okay? And you're trying to determine, hey, what is causing the tripping, right? Usually it's a faulty motor, right? Usually the winding opens or the winding starts to fail and it causes too much current and it will trip off the relay. So how do you test a motor?
Okay.
This is how you would test the motor. And here's a clear example of the positive wire actually on the case of the motor.
That's nice.
And then it's measuring one of the windings.
Okay.
So under this application, you should always read open loop. There should never be a continuity or any type of resistance from a motor winding to the metal of the case.
Oh, wow.
Right? If there is, you know you have a major problem, right? And if it's completely open, well, that's good. But in this application, you want to read a little bit of resistance. So here it's showing the same motor and both leads are attached to each leg of the winding, right? So in this case, it shouldn't be zero resistance, but it should be a very light resistance.
Like
right?
what?
Like maybe 7 ohms,
Okay.
maybe 14 ohms, just enough so that there's a resistance for the current to go through and not cause a short circuit.
Got it.
Right? And then here is the ultimate use for it, where we use it mostly. Let's say this is an underground conduit.
Okay.
Okay, like that service we were going to upgrade at that facility, right? And we pull in the underground conduits. Well, before we energize, we want to make sure none of these wires, insulation got nicked, right?
Okay.
We didn't, if it got pulled or dragged on the ground and it somehow came in contact with the conduit, the only way you can figure that out is with a meg ohm meter.
Okay.
Right? So again, the positive side would go to the metal conduit, and then the negative lead goes to each one of the wires.
Oh, that
you
makes
do
sense.
it to all the wires. You can do it to neutral. You can do it to 3 phases, right?
Okay.
Because neutral, especially if it's not terminated to the ground yet, you want to be able to determine if there's any connection between one of these phases and ground. So
that
here's a
makes sense.
perfect example of how, and mostly when you use it. You're going to test the insulation quality of a motor and on heavy wire. Right?
Yeah.
So let's say we've got, 15,000 volts,
Yeah.
high voltage wire running from a switch into a low voltage 480 volt panel, right?
Yeah.
So we come from a sectional switch. We run our underground, even if it's in PVC, okay? We run our undergrounds from the 15,000. Boom, we pop up into our outside transformer, right? Well, we want to measure that wire. We want to measure that high voltage wire before we even energize it or before we even start to splice it,
Okay,
right?
that makes sense.
So we can connect one lead on the insulation. You could literally take the wire and wrap it right around the whole insulation.
Wow.
Okay, if this will open up big enough, you can go right on the outside of the insulation, and then the other one can actually be on the little conductor that usually it's a 2-aught conductor inside of a high voltage cable, right?
Oh, okay.
You can grab onto that, and then you do your tests, and that's the difference. So, in a nutshell, they basically the same principle, okay? But you got the ultimate granddaddy that has the ultimate 1,000 volt
Commercial,
capability.
industrial.
It's highly insulated. It's acceptable. And then you have an inexpensive voltmeter. Now, even if this is a Fluke 87, even if it's one of the top rated voltmeters, it's the same thing.
Got
it's
it.
not going to put out the same as a mega meter.
Wow. Yeah, this thing looks the real deal.
Yeah, it is. It is really nice. I got to see why. The batteries just must have went on it.
Yeah.
So now let me show you those batteries real quick.
Yeah, let me see.
So you open up the back here. Okay, there's a little catch there. You pull the back off. And in fact, oh, okay, I see. So I've got rechargeable batteries in here. So you can see the batteries. Now again, there's capacitors in here.
Oh, wow, it's got its own fuse.
Yeah, it's got its own fuse. You can see it's got 6 batteries. 3 on one side. And 3 on another. And then here's a fuse, right? Because it's designed to, if you do connect this to high voltage or whatever, something goes wrong, you've got a fuse. So that's what the problem is. These are just rechargeable batteries. So again, it takes it's 9 volts, right? Because each battery is how much?
Was it 1.5 volts?
1.5 volts. Good man. 1.5. And then the next step up would be?
What?
3.2.
3.2?
Yes, 3.2. Good one, Chris. Fantastic.
3.2.
And that, my friends,
Yeah, that's the real deal.
Yeah.
I mean, I mainly do residential, so I'm not really doing too much like.
yeah, you know, residential, this is not a tool. If you're a residential electrician, you're not going to really use this. You would use this if you do a lot of cell towers.
Okay.
If you're an industrial electrician and you're doing motor repair,
Okay.
motor rewinding, you're a maintenance electrician.
Makes sense.
And it's just another way to measure at the ultimate level, and they're very highly in demand. And this is a great product.
Yeah, that's a real.
Look at this
That's
thing,
the real deal.
how beat up it is, bro.
Yeah, that's the real deal. I appreciate it.
Yeah, man.
Thank